Hi everyone, in this video we'll be looking at equilibrium of forces, and by now I want to believe you must have been introduced to this topic and also the types. So I'm going to be going straight to the point, explaining some concepts that seem to be a bit difficult. Now when you talk about equilibrium of forces, we have two types. We have what we call the static and the dynamic. Static and dynamic. So static equilibrium is the kind of equilibrium attained by a body when that body is at rest, and the type of equilibrium attained by a body that is moving with a constant linear speed or constant angular velocity is termed dynamic equilibrium. So we can also say that a body that is moving or a body that is in motion can also attain equilibrium. Now, having said that, what then are the conditions, or let's say necessary conditions, that must be met before a body can be said to be in, or before several system of forces can be said to be in equilibrium? One of them is that the resultant force on that body must be zero, and two, the resultant turning effect of that body must also be zero. So that's to tell you that when the resultant is zero, that is not the only condition that certify that a body is undergoing equilibrium. There must be two, but when you go to some exam, you will see that you only have this as part of your option. So if you have this as part of the option, please go for it and leave. But if you have two of them, please tick the two and leave. So we are going to be using a past question to verify the statement. Now look at this. This is an IGCSE question that was 2019, and if you check question 8, which statement gives a complete description of any object that is in equilibrium? There are no forces acting. That is not true. There is no resultant force. This is correct. But if you check option C, and that's why you have to be very careful, there is no resultant force is correct, and no resultant turning effect. Yes, there is no resultant turning effect. Yes, but this one is just part. This is a comprehensive statement. So you see that in this question, option C of question 8 is correct, and that is that for that. Now, having said that, we will now be looking at resultant force and equilibrium force, which is also known as equilibrance. Now, this is a single force that has the same effect as other forces acting on a body. But equilibrant is a force that balances. It balances the effect of other forces. Now, resultant and equilibrium force are the same. The only difference is they move in opposite direction. So therefore, if the resultant of a body is 15 Newton, then the equilibrant or the equilibrium force will be minus 15 Newton. That is to say that they are moving in different direction, but they have the same magnitude. Now, I'm going to be supporting that with a question. So we have question example 1. So I'm going to be writing that now. So we have a question here. Two forces, 8 Newton and 6 Newton, act perpendicularly. So in that case, I'm going to be having solution here. So for the fact that they are acting perpendicularly to each other, I have my 8 Newton here, and I have my 6 Newton here. So the question now is to calculate the resultant force. Now, if you are going by the way of the law of parallelogram, you will see that it is at the point of intersection of the two forces. That point is where the resultant force must be drawn. So you have your resultant force here, and if that is the case, of course the angle will be angle theta. Here the angle formed between the two forces is what? 90 degrees. And if you can recollect, I've said it, whenever the force between two forces, whenever the angle rather between two forces is 90 degrees, all you have to do is to apply the Pythagoras theorem. And that's what I'm going to be doing here. So I'm going to be saying, using, here I have r squared. If you check very well, if I project this a bit downward, you will see that this is 8, isn't it? And this automatically will be an angle 90 degrees. And if you check it very well, you see this is the opposite, isn't it? This is your hypotenuse, while this is your what? Adjacent. So it's always, in Pythagoras theorem state that the hypotenuse squared will be equal to the square of the what? The adjacent side. So here I have 8 squared plus 6 squared. And that should give me 64 plus what? 36. If you add them up, you will get 100. So tell me, your r will now be the square root of 100. And what will that be? That will give you 10 Newton. Now, what we want to say here is this. The resultant force is what? Is 10 Newton. Here you are asked to find the resultant force, and B is saying find the equilibrium force. So if you check this very well, the equilibrium force will be equal to minus 10 Newton. That will be your equilibrium force, minus 10 Newton. And if you're asked to show it in this diagram, look at the direction of your what? Resultant force. So your equilibrium force will act what? In the opposite direction. So this is what? The value of the equilibrium force, of course, of the same length. So if you check here, if you are going by the way of drawing, if you measure this with your ruler, if it is 5 centimeters, that means you must measure 5 centimeters here and do the needful, which is joining the 2 points. And here you have your equilibrant, and here you have your what? Resultant. In this topic, we will be looking at equilibrium of 3 forces acting at a point. Now, let's assume you have a diagram like this. We see this application almost every day. Let's say at home you have a frame that is being hung on the wall. If you check very well, sometimes you use cords, wires, threads, or anything just to make sure that they are properly attached to the wall. So in physics, there are some things that we are so much interested in, like what will be the weight, what will be the tension in the cord, and all of that. So this subtopic will help us to understand this properly. Now let's assume this is force 1, this is force 2, and this is force 3. Now in this case, whenever you are dealing with equilibrium of 3 forces acting at a point, it is good for you to apply the triangle of forces. I'm going to be applying it here. I may not actually state it, but you will understand it. Now let's see. This law is telling us that we can actually turn these 3 forces into a triangle. And how do we do that? Very simple. Now I want you to look at the first line here. The first force, which is the F3, which is this line, is going downward. I think I can just put that one somewhere here. It's going downward. And here I have my my F3. Then let's see, we have this force moving this way. So, and of course, if I put it here, you agree with me that it's very difficult for it to form a triangle. But what if I put it here? Let's see. Okay, I have what? The F3. Good. Then let's see F2. Look at F2. F2 is going this way. Oh, great. As you can see, going this way. So if I put this here, you will see that I will look at the direction. Very, very important. You will see that I have succeeded in forming a triangle from this diagram. So what this is telling you is simple. It's saying that if you are to form a triangle from these 3 forces, these triangles must be taken in order. That is, if you check the direction of this force, you will see that it is the continuation of the second one. And if you check this was actually F1. And if you check this was actually F2. You will see that these 3 sides of this triangle are actually taken in order. That means, see F1 going down, it conforms with the direction, it conforms with the direction of what? F1. And if you check from here, this one also conforms with the direction of what? F2. This is what examiners will look out for. And trust me, if you do not do the right thing, you will start losing marks from the diagram. So now let's see application of that. I have a question here. If you check this question very well, you will see that this question is talking about a frame of weight 20 Newton hangs freely by 2 identical cords. What is the tension in each cord? Take the angle formed between the cords and the frame to be 60 degrees. Now, what this is telling us is this. Let's assume on the wall, there is a point on the wall, and we have a frame somewhere here. We have a frame somewhere here. Could be the frame of your 20th birthday, frame of your 10th birthday and all of that, or maybe when you were 2-year-old, that it snapped you, and you have this frame looking beautiful on the wall, and this happens to be your picture and all of that. You have pictures here. So let's see now, if this is the point of attachment, it is very easy. You will see that tension generally acts towards the point of what? Attachment. So, and this is also a tension here. It will be acting this way. I can call this one T1 and this T2. But for the fact that we were told that they are identical, so I think the tension in them will also be identical. And that's not all. You will also see that they are also forming the same angle with the frame. So now let's see, the angle formed, not here, but here. The angle formed here is what? 60 degrees. While the angle formed here is also what? 60 degrees. So this is the diagram. And of course, the weight of this frame will be acting downwards, and that is what? 25. If you check very well, you see this is 25 Newton. So let's see if that is the case. There is no way I will just solve this without making 1 or 2 mistakes. I can just say, okay, if that is the case, why not do some simple work here? Like let's change everything here, or let's do it this way. Remove the designs and all of that. Let's give or draw the shape of the frame of the forces acting on it. We have one here, sorry, we have another one like this, isn't it? Yes, and we have another one like this. This is 25, isn't it? We have one here which is T. We have another one here which is what? Which is T. So from this, let me see if I can form a triangle from there. So let's see. I have a line going down. I have a line going down like this. This is what? 25 Newton. Yes. So let's see. I have one going this way. So if I'm to put it here, check. This is the direction here. This T here, I think it can come this way. Check it very well. Look at it. Yes. This will work. Okay. Very good. Then what about this? This other tension is actually going up. So imagine you bringing it somewhere here. You will see that it will perfectly fit into this diagram. So now let's see. This is actually going up, as you can see. I'll call that tension. And this is actually also going up. I'll also call this tension. And let's see if actually we've gotten the diagram we're looking for, which is they must be in order. It's going this way, yes. This way, yes. This way, yes. And that settles it, isn't it? Very good. Now let's see. Looking at this, you will see that the angle formed here is what? Is 60 degrees, isn't it? Yes, the angle formed here is also what? 60 degrees. So that means if you are to look at this, if this line, if this tension is to be formed somewhere here, as you can see, this will now come this way, isn't it? Let's see. Look at the sketch here. Look at the sketch here, something like this. So that it won't be so confusing. I think it looked like this. Yes, it is. Looking at this, yes. Wow, perfect. This is 25 Newton. What about this? Okay, this is my tension. I have my tension here, and this is tension. Now let's see, this angle formed, the angle formed there is what? Is 60 degrees. That means the one that will be inside this triangle will be what? 30, isn't it? Very good. So the same thing, look at this also. If I'm to replicate the same thing here, I want you to look at it. This is also the what? The weight, 25. So let's see if this is this. Look at this. This is this line here. Very good. So this is also going this way. So can we see? Oh, perfect. Forming the same triangle taken in order, as you can see. So the same thing here. If this is what? 60, what would this be? This is also what? 30. That means they are both forming 30 angle 30 degrees with the what? With the weight of this body. So that means this side is this 30 here. Yes, this is 30. So quick one, let's come back to our diagram. That means here you have 30, here you have 30. Of course, I can just do something here so that anybody checking this will get it properly. Now let's see, if this is 30, this is 30. Sum of angle in a triangle is what? 180 degrees. That means this angle here will be 120 degrees, isn't it? Very good. So from here, I can calculate my tension. I can calculate the tension in this spring. So let's see if that is the case. I can just go on and use the sine rule. Let's see, using the sine rule. Using the sine rule. And if you are using the sine rule, what would that be? That means this side, check it very well, you will see that the angle facing this, the angle facing here, and the angle facing this. So that means this 25, let's check, 25 will be divided by sine what? 120 degrees. Yes. Tension will be divided by what? Angle sine 30 degrees. So we have this sine 30 degrees equal to this tension will also be divided by sine 30 degrees. So with what I have here, all I have to do is solve for one, and the moment I get one, that means the two forces will take that value. So let's see quickly. This is going to be 25 over sine 120 degrees. That's what I'm doing, and I'm just comparing with one of them. Very good. So from here, what will be my tension? My tension will now be 25 times sine what? Sine 30 degrees, all divided by sine 120 degrees. Don't mind me, I'm actually looking at supplementary angles here. So if that is the case, let's see how this works. This is going to be 25 times what? Half, isn't it? 0.5. And this is going to be divided by 0.8660. And you will see the answer will be 14.4 Newton. And that is the value of the tension in the courts. Now in this question 2, I want us to look at this very well. A handbag containing some load weighing 162 Newton. Of course, the weight of any bag or any object will always act where? Downwards. So we have it to be 162 Newton. Now, this bag is being carried by two students, each holding the handle of the bag next to him. So that means this bag, if this is a bag, you agree with me that let's assume this is an handle. This is also another handle of this bag. Yes, very correct. And if you are holding, that means you are dragging it towards you. Yeah, you're also pulling towards you here, and that means here there is going to be a force or a tension in this spring or in this handle, in the handle of that bag. Yes, very correct. So let's see what happens next. Now, if each handle is pulled 60 degrees to the vertical, that means here, let's just extend this. If you're pulling here, so here you are now pulling 60 degrees to the vertical. Here the same thing, you're pulling 60 degrees to the vertical. So if that is the case, the next thing now is we have to find the force on each student's arm, and that is this T. And for the fact that they both made angle 60 degrees to the vertical, that means they are what? They are of the same value, they are of the same magnitude. So we'll go on and start solving for this. Now in this question, we are going to be solving it in two different ways. Now this will be the first method, so I'll call this method 1. So in method 1, we are going to be using resolution of forces. Resolution of forces. So what do we do under resolution of forces? Very easy. We resolve these forces horizontally and what? Vertically. So let's see. If this is 60, this line, let's just, since we are resolving, so that means we have a 4 cardinal points somewhere here. And if that is the case, if this is 60, this is also 60. Alternate angles are equal. 60, 60. Very good. and this is 90. So if this is 60, what will this be? This will be 30. And what about this? This is also 30 degrees. So that means here we are making use of the angles. The two arms are making with what? The horizontal. So if that is the case, if I'm resolving this, and for the fact that I have this, mind you, they are of the same magnitude. If you resolve it horizontally, that means this will nullify this. So there's no point doing that. So that means the only thing we will do here is to what? Resolve vertically. So if you resolve vertically, then you have it being equated to what? 162. And then what will be our answer? Let's find out. So if that is the case, we're going to have something like this. Resolving forces, number one. So let's say here we have forces. Here we have forces. Here we have the vertical components. In short, that will be our Fy. And here we have the what? The horizontal components. Okay, in short, so that means you have Fx. So here we're going to be resolving vertically and what? Horizontally. So what are the forces? We have T. So of course we also have T here. So if I'm resolving this force vertically, what will be my answer? Is going to be T sine. The angle is making with what? Horizontal, which is 30. So here you have T sine 30 degrees. And for the fact that here it is what? It is vertical and it is along the what? Positive y-axis. So it's going to be plus. Now let's check for this other one. Very good. It's also going to be plus, and it's going to be T sine 30 degrees. T sine 30 degrees. Now what about the horizontal? I mentioned it, but let's just see. Let's solve for it. If you solve this horizontally, you're going to have T cos 30 degrees. And here is positive x-axis. So you have T cos 30 degrees. And what about here? Horizontally, that will be minus, because here is minus x-axis. So here is going to be minus T cos 30 degrees. Minus T cos 30 degrees. And that was exactly what I was saying the other time. And if you do your summation here, what will be your value? Of course, you have your force also. We have our force. And so what do we have for force? We have here, you're going to have 0 here, no doubt. Yes, because this will cancel. And here, okay, you want to solve for 162. Why not? Let's solve for 162. What will be our answer? So this is going to be, if I'm resolving this vertically, what will be my answer? Vertically, I'm going to be having 162 sine 90 degrees, because the angle is making here is 90. So this is going to be 162 sine 90 degrees. And if you want to solve for what? The horizontal component is going to be 162 cos 90 degrees. And of course, you all know that cos 90 will give 0. So there's no need for us bothering ourselves on this. So if that is the case, sine 90 is 1. And that means the answer to this one here will be what? 162. So if that is the case, if I'm solving for t, that means I'm going to, if you check, these two t's, they will be in the what? They will be in the same direction, and they will be what? Opposing the weight of this body. And if they are opposing the weight of this body, I said this is going to be vertically, and you see that the two of them here will be opposing this weight of the body. So that means I can actually add them up and equate them to be 162. So that's exactly what I'm going to do here. So that means upward forces, let's have it that way, upward forces equals to what? The downward forces. Downward forces. So if you do that, what would that be? Upward forces will be your T sine 30. So that means I have T sine 30 degrees plus T sine 30 degrees. Okay. And that will be equal to what? 162. So you may want to add that. Yes, that will be 2T sine 30 degrees equal to 162. And sine 30 is half. So that will be 2T times half. And equals to 162. This cancels. You have T. You're going to have T equals to what? 162 Newton. So that means our force is 162. So if this is 162, of course the other tension will also be what? 162. Now, having said that, the second method will be by the use of the triangle law of forces, and which will automatically result into the Lamin's theorem. So let's see. Let me just put it there, using Lamin's theorem. That's the modernized form of sine rule. So let's see. Looking at this diagram, if I want to redraw it here, that makes it a bit clearer. Check it out. This is the force acting, this is another force acting, and this is the weight 162. Now we've already agreed, check here, we've already agreed that the sum of this force, we've already done this here, whereby we have 60 alternate angles are equal, isn't it? So that means if I want to use my Lamin's theorem, what I'm going to do here is I'm going to add up all these. I will add up these two angles, and if you add them up, what will you get? You will get 120 degrees. So let's see. Here I'm going to add up these two also. Yes, I'm going to add up these two, and if I'm adding up these two, that means I have 30 plus 90. What would that be? That's going to be 120 degrees. So here also 30 plus 90 will also give 120 Newton. And if that is the case, then from here I can now use my Lamin's theorem. So what's Lamin's theorem saying? It's just the same thing. You just find the ratio of the force and the sine of the angle that is directly opposite it. So here I have 162. 162 is directly opposite 120, so that will be sine 120 degrees, equal to the tension here is also directly opposite 12. So I have one sine 120, that's 120 degrees, isn't it? Very good. And of course, if you want to do for the next one, in case you are given two different forces, this is also going to be T, and that means you also have the same 120 degrees. So in this case, I'm just going to solve for one, and from there I will get my tension. So this is going to be 120 equals to T over sine 120 degrees. So tell me, sine 120 degrees can cancel 120 degrees. I have my tension equal to 162 Newton. And if you check from the one we've solved, you see that we equally got 162 Newton. 162 Newton. So in any formula you use, you will get the same answer. So now someone is now asking, why not use the triangular law of forces? Let's give it a try. So that means that will be our method 3. Okay, yes, or let me do it this way, so that makes it a lot easy for me. So for the triangular law of forces, so let me just say method 3 here. So yeah, check it very well. We want to take these triangles in order. So first thing, let's see. Yeah, of course, this is in the direction of the weight. They are in the same orientation. So yeah, let's see. I have my weight somewhere here, which is 162 Newton. So let's see, the other force here is actually going up. So what if I do it that way? Okay, it's going up, and that is what? That's T. Now let's see, if you check, this is in the direction of the tension and weight, isn't it? You will see that it's making angle what? 60 degrees with the what? With the weight. So yeah, I'll come here and put 60 degrees with the weight. Then let's see, look at this one, is actually going this way. So that means here I will have this to be this, and it's actually going up. This is also tension. So if you check these three now, you see that they are actually taking in order. Yes. So now let's see, this angle here is actually making angle 60 degrees with this straight line, which is taken to be the weight. So here it's going to make an angle 60 degrees with the weight. So in that case, sum of angle in a triangle is what? 180 degrees. So if I had this, of course the answer here will be 60 degrees, which is to tell you that this is an equilateral triangle. So if that is the case, I can still come here and use my sine rule. Yes, let's see, 162 is directly opposite this. So let's see, using sine rule. So if that is the case, you have 162 over what? Sine 60 degrees, which will be equal to the tension, which is also directly opposite 60 degrees. So you have sine 60 degrees there. So if you check very well, this will cancel this, and you will still have your tension to be 1 162 Newton. Even if you have to solve for the next one here, you will still get the same answer. And that is to tell you that the three methods are giving us the same answer. So if you do it very well, if you do it correctly, you will get the same answer. Thank you.